are going to do our function recap. We're going to go over this function transformation page. So go ahead and flip your packet to this page, and we're going to just kind of once again go over this stuff. I feel like we've been going over it over and over and over again. So we just want to really make sure you understand it. So this first one is a vertical shift up. This is kind of a good cheat sheet. So when you have f of x plus k, remember we talked about when the when the extra value is outside the parentheses, this is going to be a vertical shift, or it's going to change the range. It's going to change R for range. So if I put R, that's going to mean range. And if I put D, change in the range, change in the domain. So this is going to change your range by k numbers. So if we have our original function is the parent function of the parent quadratic function, and our new one is they're asking us to graph this, then we're going to move up 2. So right here at the vertex, we're going to go up 2 points and then graph the exact same shape, just up 2. So what happens is the range changes and we add 2 to the y value. So for an example, if you picked a point at -1, it would have been -1, +1. The new point would be -1 adding 2, 3. And let's check that out. So if we had, this was our original point at -1, 1, the new point is going to be -1, 3. And all you're doing is adding 2 to the y values there. All right. Now, if we have a vertical shift down, so this is adding k, this is subtracting k. Well, now the new parent function is our radical function, which looks like this, kind of a half of a parabola. If they're saying, okay, we're going to shift that down, this is still going to be a change in the range. It's just going to take this point right here, it's on the origin, and you're going to shift that point down. So our new graph is going to look exactly the same. It's just going to be like this, okay? So let's pick another point. If we picked, say, this original, say x was 3, or no, I'm sorry, let's say x. Let's give us an easier one than that. Let's say x is 4. Then our y would be 2, right? Because the square root of 4 is 2. Well, what we're going to predict is then the 4 would stay the same, and the y would then be 1. We would just take that y and subtract 1. Well, let's look. So if we had over here 4, 1, 2, 3, 4, 2, that's going up 2, right? Then we're predicting the new graph would be at 1, 2, 3, 4, 1. And sure enough, it's right there. So that's what we're talking about as far as being able to predict where the new graph is. We're trying to predict it algebraically as well as visually. So then we go to our horizontal shift. Now these are within the parentheses. So this is going to be a change in the domain. So we're going to add or subtract to the domain. Now keep in mind, we talked about how when it's in the parentheses, it's the opposite. So we're going to do the opposite, okay, when it's inside the parentheses. So if our function that we're talking about is our absolute value of x, we're going to look here and it's saying x minus 2. So we know that that's actually going to shift to the right, 1, 2. It's shifting opposite. So that new graph is going to look like this. All right. It's shifted to the right 2, which means we're going to add 2 to the x values. So here we subtracted, I didn't write that, subtracted 1 from y values. Here we're going to add 2 to the x values. So if our original point was, say, let's just pick this point right here. What is that? That is 1, 2, 3, 1, 2, 3. So that's negative 3, 3. And our prediction is if we add a 2 to the x, then that would, our new line, our new point would then be negative 3 plus 2 is negative 1, 3. Well, are we correct? So we're going to look and go to negative 1, 1, 2, 3, and sure enough, there it is. So that's kind of, hopefully this is starting to make sense. Anyway, what about this one? We've got this horizontal shift left because now this is a plus, right? We do the opposite. This again is inside the parentheses. It's a change in our domain. We're going to do the opposite. So this quadratic graph that looks like this is going to get shifted to the left too. So the new graph is going to look like we're taking the vertex right at the 0, 0, and we're not doing anything other than shifting it up. So our original point, let's just say we picked negative 2, 4. We're going to predict that we are, instead of adding, we're going to subtract. Let's put that in blue. We are subtracting 2 because we're doing the opposite. So when we subtract 2, negative 2 minus 2, we're going to get negative 4, and the domain, the range stays the same. So let's see if that actually works on our graph. So the red graph was the new graph, and the original point was supposed to be negative 2, 1, 2, 3, 4. The new point, negative 4, 1, 2, 3, 4, negative 4, positive 4, right here. All right, so that's kind of, hopefully, let's see how this also goes. So now we've got a reflection over the x-axis because we're seeing how this is outside, the negative is outside the function, it's not within the function. So it's going to reflect over the x-axis, okay? It's just going to flip down. So our original graph is this radical graph. And now when we flip it down, it just literally goes boop. So our new graph is going to look like that. Okay? And the way that this changes, of course, since it's outside, this is going to be a change in our range. And what we do for these is we take the opposite of the y values, of y value. So instead of, if it is x is, say, 9 and y is 3, which would be way over here, then the new graph, it would be 9 would stay the same, but we're going to take the opposite sign, which would be negative 3. And that goes both ways. If it's negative, then it becomes positive, so it's the opposite. All right, and you can see how if we went to 9, that would that would work. All right. Now this is the reflection over the y-axis because the negative is inside the parentheses. So this is going to be a change in our domain. Oops, I'm writing it down. Change in the domain. So now we're reflecting it over the y. So instead of here, we're going to flip over there. I don't know why my hands are dirty. I've been doing these all day, these videos. So we've got, here is our original. And then I'm going to flip it over to the y-axis. So our change in domain, the range is going to stay the same, but instead it's going to just flip over that way. And so what we're going to end up doing is we are going to take the opposite, you guessed it, of the x value. So instead of having, in this case, we said 9, 3, but in this, the blue graph would actually then be negative 9, positive 3. Okay? All right. Moving on, vertical stretch. So we've got, this is when we are getting it skinnier or fatter. So with a vertical stretch, it is getting thinner, or it is getting closer to the y-axis. It's a vertical, stretching it closer to the y-axis. When an f of x is when a is greater than 1. So for an example, just anything bigger than 1, 2, 3, 4, 5, 6, 7, and it includes negative 2, 3, 4, 5, 6, 7. Keep that in mind. It just is going to flip down, but the negative numbers, it's when a, it's like the absolute value is a is bigger than 1. It gets closer to the y-axis. So we've got, this is a, graphing this, it's going to be up like that, where it just gets closer to, oops, hit that mark, closer to the y-axis. And what happens here is you multiply, this is going to be your change in your range, because it is, the a is outside, you're multiplying outside the parentheses. You're going to multiply the y values by a, or in this case, 2. So if we had a point, say, negative 4, 4, then, oh, I didn't mean to do that. Shoot, I meant to do this one in blue. Darn it. So if we have this negative 4, 4 is the red graph, the original parent function. Then the new graph, the blue graph, we would multiply the y value by, in this case, 2, which is right here. So then this would be negative 4, 8. Okay, and you can see how we went to 1, 2, 3, 4, then 1, 2, 3, 4, 5, 6, 7, 8 would be right about here, and that's where it's heading. Okay, now vertical shrink. This is where your a is between 0 and 1. And again, this is basically, so it's between 0 and 1, it's the absolute value of that, meaning that even if it's negative, then it still falls, it stays within here. Okay, so my original, let's get this right here, is the red. This is my parent cubic function. Then what I'm trying to do is I'm going to shrink it closer to the x-axis by 1/4. And so then that is actually going to look more like this. Going to get closer to that x-axis. So this is actually going to change my range. Sorry, it's changing my range because it's outside the function here. And what we're going to do again is you're just going to multiply, just like we did before, multiply the y's by a. So here we do the exact same thing. So if we just use that same example, if we did negative 4, 4, in this case, our graph would move to negative 4, 2, because, oh, I'm sorry, to 1. I'm thinking 1/2. It's 1/4. It would be 4 times 1/4 is 1. So at negative 4, 1, 2, 3, 4, that should be way out, like that. It would be like that. 1, 2, 3, 4, way out. That is not very pretty. Let me fix that. Still not super pretty, but you get the idea. I did not give that enough stretch or shrink. Okay. Last but not least, we're talking about a horizontal stretch. Now the horizontal stretch is when it's inside the parentheses. So this is going to be a change in our domain, right? So if our original quadratic function looks like this, then we look at this and it's saying, okay, if we have 1/2 of x, and basically what this is saying is 1/2 of x squared would then be 1/4 x squared because you were squaring that 2 at the bottom. So that's what this means. 1/4 x squared. So when we have this, we are going to multiply the x values, right, by 2 because it's stretching by a factor of 2. Stretch by a factor of 2. Okay, even though it turns out to be 1/4 x squared, this is what your factor is. This is what you're looking at. This is what's happening. All right, so now when I graph it, it's going to go out like this. So if I were to have, say, x squared was, let's just say we were going to do 2 and 4, we would then multiply the x by, oh dang it, I put that in the wrong color. So our original was 2, 4. This should be red because that's on our original graph. And the new blue graph would then be multiplied by 2. So then it would be 4, 4. So original 1, 2, 1, 2, 3, 4. And then the new 1, 2, 3, 4, 1, 2, 3, 4. Almost got it. All right. And the very last one, the horizontal shrink. I better put this in red right away so I don't screw that up. Here's your absolute value. This is basically saying that this, by a factor of, this is going to be a change in your domain. But this is by a factor of, remember, since it's inside the parentheses, it's the opposite. So it's the opposite of 4, so it'll be the factor of 1/4. Okay? So you're going to take your original, you're going to graph it. It's going to be, I think it'll be like this. Not skinny. And so then if you take our original point, say of 4, 4, hold on, I gotta let my dog. Alright, so we've got 4, 4, so we're going to multiply the x by 4. And so that's going to be 1/4 times 4 is going to be 1, 4, and if you notice it would be 1, 1, 2, 3, 4, which is right there. Alright, so that's the end of this. Hope that helps. We are going to talk about this next page next.